We are looking at question number 5. And question number 5 starts off the video here. And this is number 5 from the Unit 3 review, the paper review. Okay? All right. So let's go ahead and do this. We have f at x equals 16y to the 4th minus 81. I have to factor this out. All right. So if I factor this out, I know this is a difference of perfect squares because 16 is a perfect square and so is 81. So this becomes 4y squared minus 9 times 4y squared plus 9. And I can further factor 4y squared minus 9 out to get 2y plus 3, 2y minus 3 times 4y squared plus 9. Okay, that's how that factors out. That's the first thing I have to do. Now, what I'm going to do is find the zeros. I actually have more than 2 zeros. I have 3 zeros. So I'm going to set each one equal to 0 and solve. So 2y equals negative 3, y equals negative 3 halves. Okay? Okay, so my first 0 is at negative 3 halves, comma, 0. Okay, and by the way, there's a typo here. That should say 16x to the 4th. So let's do a little change here to make this a little bit better. And there we go. Okay. All right. The next one, 2x minus 3 equals 0, 2x equals 3, x equals 3 halves. Okay, so 3 halves, comma, 0 is my next 0. And finally, I have 4x squared plus 9 equals 0. We're going to get into trouble here because when I have x squared equaling something negative, I know that's an imaginary number. Okay, so I'm not going to include that because it's imaginary. All right, so I have my 2 zeros. Now I have to state my multiplicity. So since this first one, 2x plus 3 is to the power of 1, the multiplicity is 1. And since that multiplicity is 1, it's considered to be odd. The behavior is the graph goes through that point and keeps on going. Okay. The multiplicity for the next one, 2x plus 2x minus 3, is also multiplicity of 1, which is also odd, and the same thing is going to happen there. State my y-intercept. I'm going to let x equal 0 for my y-intercept. So this becomes 16 times 0 to the 4th power minus 81, and that equals negative 81. So my y-intercept is 0, comma, negative 81. What's the maximum number of turns? To figure that out, you take the highest power of the polynomial, which is 4, and subtract 1 from it. So the equation is n minus 1. So the maximum number of turns is 3 for this equation. Okay, let's look at the next one, number 6. The same kind of question, find the zeros, state the y-intercept, maximum number of turns, etc. All right, so we have x cubed plus 3x squared minus 4x minus 12. I see 4 terms, so what I'm going to do is try grouping. So I'm going to group 3x plus 3x squared together, and I'm going to group negative 4x minus 12 together. The GCF of x cubed plus 3x squared is x squared, and I get x plus 3 here. And I can factor out a negative 4 out of negative 4x minus 12. And when I do that, I'm left with x plus 3 again. This is good because now I have x squared minus 4 times x plus 3. Now, x squared minus 4 breaks up into x plus 2, x minus 2. So when I factored everything out, this gives me x plus 2, x minus 2, and x plus 3. Okay, so I have 3 zeros. All of them are to the first power, by the way. So I'm just going to put 0 number 1 is going to be x plus 2 equals 0, x equals negative 2. So 0 number 1 is negative 2, 0. 0 number 2 is x minus 2 equals 0, x equals 2, 2, 0. And the third one, x plus 3 equals 0, x equals negative 3. So the third one is negative 3, 0. All of these are factored out to the first power, so their multiplicity is 1. Okay, and I'll just write 1 again. So that means the behavior, since the multiplicity is odd, it goes through the points listed and keeps on going. By the way, if you got a multiplicity of 2, that would mean something like this, x minus 2 squared. You know, if I had 2 of them, then it would be even, and that means it goes to that point and it turns around. So you'd see a turn there. I just wanted to point that out. So state your y-intercept. You have to let x equal 0. So if I do that, I get 0 cubed plus 3 times 0 squared minus 4 times 0 minus 12. So I get 0, negative 12. And maximum number of terms, again, is found by taking n minus 1, where n is the highest power of the polynomial. And in this case is 3. So 3 minus 1 gives me 2. So the maximum number of terms is 2. For this one, we have to graph the function. All right, so I'm looking through here, and I have negative 2, 0, negative 3, 0, 2, 0, all the multiplicities, right? So I'm going to graph all these points. So before I do, I have to list this out. Okay, so I'm going to put negative 2, 0, negative 3, 0, and 2, 0 here. Now, in order to get some clarity, I'm also going to look at the end behavior. And to do that, you have to look at the leading coefficient, which is 1x cubed. X cubed, 3 is odd. So that means I'm going to have either this situation where I'm going to fall and then rise, or rise and then fall. To figure out which one's which, I have to look at that coefficient of 1. 1 is also odd. So when that happens, when you have a positive coefficient, the left is going to fall and the right is going to rise. So I have this situation. So I know on the left of this is going to come up like that. Now remember, at negative 3, it says it goes through it. So it's going to have to turn at some point to hit this next one, and this next one it goes through. Now the other thing I forgot to graph is my y-intercept, which is clear off the map here. It's like, I'm going to put this as negative 12, okay, just to let you know. So this is what's happening there. Now, it has to turn again to get back up to this. And remember that the end behavior on the other side has to do this. So we see the maximum number of turns is 2. Here's the first turn. Here's the second one. So that's how you would graph that function. All right, I'm going to start with number 7 for the next question. Thank you for watching 5 and 6.